Okay, let's take a look at MIDI in MaxMSP. We're going to start by generating MIDI directly within the program, and then we'll get on to how to use external MIDI gear. To start, I'm going to create a new object called Kslider. Kslider displays a virtual keyboard. If I take a look at the inspector, it tells me that this has a low MIDI key offset of 36 and a number of notes of 48. It's currently set to display in monophonic mode and input is off. Good stuff. If I take a look at the help file, it tells me that Kslider outputs and displays note and velocity information using the on-screen keyboard. In fact, the left outlet is going to be the key value or pitch in MIDI notes, and the right outlet is going to be the velocity from the mouse height on the keyboard. If the mouse is at a lower vertical position, the velocity will be lower, and if it's up higher, it will be louder. But that doesn't really do anything for us just yet. So I'm going to create a new object called Makenote. Makenote takes a couple of arguments. It takes a default velocity, a default duration, and a default channel. I don't need to use the channel right now, but I will give it a default velocity of 64 and a default duration of 250 milliseconds. Now, I'm going to connect the pitch outlet of Kslider to Makenote. I'm going to connect the velocity output to Makenote's velocity. If you're ever in doubt as to what an inlet does, remember that you can hover your mouse over and it will tell you. This is pitch, but it's also red colored, which means it's the hot inlet. So this will trigger Makenote to output its values. This is velocity, and that's duration. So right now, we've got a pair of notes. The reason why I did this is because by default, if I just take a look at what's coming out of Kslider, I'm going to use a message box to show you, connecting to the cold inlet of the messages so that you can see this. If I click, I've got a pitch, I've got a velocity, but that velocity never turns off. It's always there. If, however, I take a look at the output of Makenote, watch this. Still have a pitch, but did you catch what happened with the velocity? Hey, it changed. After my duration of 250 milliseconds, the velocity, which was 26, jumps down to 0. This is really fundamentally important because in MIDI you have a note on and a note off message. They both have the same pitch number, but the note off is 0 for the velocity. Using this, I can start playing notes. Let's take a look at note out. By default, note out is just going to transmit to my basic synthesizer. If I click on that, it brings up a list and I can send it. I've got pitch, I've got velocity, and I've got channel. Let's hook it up and see what it does. Just the basic piano sound that's built into General MIDI. This will work on both Apple or Microsoft platforms. It's not too interesting though. What I'm going to do instead is I'm going to create a very, very basic sine wave synthesizer. We already know the cycle object, so let's use that. Cycle, though, takes information in the form of frequency, not MIDI notes, so I have to convert that somehow. Fortunately, there's an object for that. It's called M2F. If I connect the pitch coming out of Makenote to M to F, you can see that what it outputs is a big decimal number with frequency. So there's my A at 440 hertz. Here's middle C at 261.62 something hertz. Here is A 880. Here is C above middle C at 523.25 hertz, etc. Those values are something that cycle can understand. So I'm just going to connect it up to cycle, and then I'm going to use that to create sound. But there's a slight problem. Let's take a look with a gain object. And then we'll connect that, as always, to easy DAC. It's not turning the note off despite what's coming out of here on the velocity. That's a bit of a problem because I don't want this constant droning sine wave to go on forever. Let's fix that. The easy way to do it is to use an object called ADSR. ADSR stands for Attack, Decay, Sustain, Release Envelope Generator. Takes a number of arguments. The first is the attack time. I'm going to give that 10 milliseconds. The decay time, let's do 220 milliseconds. The sustain time, the sustain percentage, not time. This is going to be a floating point number from 0 to 1. I think I'm going to do 0.8. That's going to be 80% of whatever the maximum velocity value that it receives is. And then it has a release time. So this is from when it goes to 0 until effectively the note will die away. Let's say 250 milliseconds. So what's going to happen is it will receive a non-zero value. That will cause it to ramp up over 10 milliseconds, drop down to its sustain rate as long as the key is being held over 220 milliseconds, sustain at 80% of the velocity that it received, and then as soon as it receives a 0 in here, this will change and it will slowly ramp down over 250 milliseconds until the note is effectively 0 and completely silent. There's one slight problem though. You'll notice that the output here for the velocity is anywhere between 1 and effectively 127. What I need to do in here is to convert that value into 0 to 1. There's two ways I can do that. First, I can do divide by 127 decimal point. Decimal point is really important because that will give me a floating point number. Without that, let's see what happens. So I'm going to copy this over and get rid of the decimal point. Then we'll just connect a message to each of those. Well, that's interesting. I get 0 to 1 with a bunch of decimals here, but over here, because it doesn't have that decimal point, it thinks that I'm dividing and creating an integer, so it will only give me 0 or 1. It rounds up. So it will only affect a value of 127 and take that to give me full 100% volume. That's a really important thing to keep in mind. So I'm always going to want to use floating point values as much as possible. The other way that I can do this, instead of having to use that divide, is I can use probably my favorite object. It's called scale. Scale maps an input set of numbers to an output set of numbers. And you can mix integers and floats here. So let's do 0 to 127 because that's the MIDI range for velocity. And then we're going to go 0.1 point because that is what we want for ADSR values. Now, this is going to give me the exact same set of values for both. So either of these is going to work. For the sake of simplicity, you could use divide but for stuff later on, you're definitely going to want to use scale when you're going between ranges. Now, before I dump this into the gain, that's going to be a bit of a problem because the gain does not understand 0 to 1 values, and I don't really want the gain going up and down. I want that to control my maximum fader value. So I'm going to create a new object, multiply tilde, because this is going to be using audio, and anything that has audio has to have the tilde, and then 0 point. I connect the cycle into the hot inlet, I connect ADSR into the cold, and then I connect that to gain. Turn it on. And we have a really basic working sine wave synth. You'll note that there's no sustain though, because Makenote does not give us the option to add sustain. So effectively, this is just an attack decay envelope, but it works.